Welcome to episode 288 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. And in fact, I should share, I got fancy speed upgrades on my network. So I don't know. I just thought that was fun. I have managed to clock 1.2 gigabits download.
Ooh, that is exciting.
That is just once, though.
Okay. Yeah, for our listeners, we do sometimes struggle a little bit with internet connectivity on your side. Like sometimes your video goes a little bit bad, especially at the end of the episode while uploading, but hopefully that will be a thing in the past.
And I'm starting to get suspicious it's actually my laptop overheating. I'm
Really?
serious. Yeah. And CPU throttling. So next step will be one of those stupid laptop cooling fans and see, and then I don't know where I'm going from there.
Okay. I have not seen those laptop cooling fans. Is that really something that would be necessary? I don't know.
Oh, well, when I can feel the
fans.
heat of my laptop
That's
through
true.
the bottom of my desk,
Oh, yeah. Okay.
or through
Sounds
the
like you might
bottom
need
of the top of the desk, yeah, then it makes me wonder.
Okay. Well, at the top of every episode, I like to read a piece of feedback. This week, we got an email from Artemy, and he writes, I really like your podcast. In one of the latest episodes, you've mentioned C++ COM interoperability and how it became easier nowadays. I really like to hear more on this topic, especially for Win32 applications. I would think that Raymond Chen is a good candidate for discussing this topic, who's, of course, the author of the Old New Thing blog. Looking forward to hearing any new episode of your podcast. Thanks for doing a great job. It'd be great to talk to Raymond Chen. I don't know how available he might make himself for, something like a podcast. I'm not aware of him doing any like public speaking, but obviously his blog is very well known.
Yeah, I mean, I've been aware of Raymond, I think, as long as I've been programming in C++, approximately the same era that I learned about Herb. So, yeah, he's been around for sure. And we've mentioned his article several times on here.
Oh, yeah, we've had several of his articles in the news over the past few years.
Yeah.
But, it's worth at least trying to email him and see if he's interested in coming on. So I will definitely be doing that.
Cool.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Nicole Mazzuca. Nicole is a software engineer at Microsoft working on the Vcpkg package manager for C++. She graduated from Western Washington University in 2019 with a degree in mathematics and was hired out of school by Microsoft to work on Vcpkg. Since then, she both designed and implemented two of Vcpkg's major new features, manifests and registries. She has been involved extensively with Rust in the past and is a founding member and moderator for the Include C++ community. Nicole, welcome back to the show.
Thanks. Hi, y'all. How are you doing?
Doing good.
Good. How are you doing?
Really good.
I feel like we should mention, due to a slight miscommunication here, Nicole did not get access to the articles. So
about 2 minutes ago.
Yes. So if she doesn't have anything to add, it's our fault.
Yeah. But yeah, so Nicole, we'll discuss these. Do feel free to comment on any of them, and then we'll start talking more about what we mentioned in the bio, which is those new Vcpkg features that you worked on. Okay.
Cool.
All right. So this first one is an article on solving differential equations with LLVM, and there is a GitHub link in here. The library is called Hyoka, and I have not done differential equations in a very, very long time. So I don't think this is something I would make use of, but they're making use of LLVM's JIT capabilities, which we discussed on the show recently, right, Jason?
Yeah, that at least came up maybe last time we talked to Ben Dean, I believe.
That sounds right. Yeah.
Something like that. Yeah, so, I mean, this looks pretty cool if you're, into solving differential equations.
Yeah. Yeah. Looks very cool, very powerful. I'm sure it is very fast with the use of the just-in-time compilation LLVM. But, differential equations, that just brings back nightmares from my time in college. I do not remember, have good fond memories of that at all.
Nicole's much closer to university than either of us.
Yeah, and Nicole,
you
got your degree in math, didn't you? Yeah.
Okay. Actually, I had a really good differential equations teacher, but I still didn't understand any of it. So I am not the person to ask about this. I prefer things that aren't numbers. Like numbers, too much for me.
I don't. For some reason, I feel like I didn't have to take differential equations. Maybe I did, and I just completely blocked it from my memory. But the highest level math class I recall taking is multivariable calculus, Calc 3, is how it was split up in Virginia Tech.
I did computer engineering, not comp sci. So maybe
Oh yeah, you had to have more
engineering.
Yeah. And my wife has a math degree, so I know she took all these things.
She know her differential equations? Maybe she can come on.
Yeah, why not? Well, I told her what this project was about, and she, seemed to at least think it sounded interesting, I guess.
Okay.
Yeah, I think it's cool, like, that they're using the JIT for this.
Mm-hmm.
It's like the perfect thing to use JITs for, It's like creating programs at runtime and then compiling them. Like that's the perfect use case for JITs.
Yeah, that's true.
I think it's neat anyways.
One of the projects, I've mentioned that I do energy simulation stuff with one of my clients. They've got some project that we're integrating on the side right now that does like, and not a project that we wrote, but a project that we're using that generates the problem set in like Java and then uses a JVM with its JIT to actually then solve the problem. So it's kind of like custom recompiling the problem at the same time too.
Yeah, that sounds really cool. The one concern I would have is like, I don't know how fast LLVM's JIT is. I know it's not as well taken care of as Java's or like C Sharp's. So I would be curious if this would be faster if it was doing the same thing with like doing JVM or doing CLR or doing even like JavaScript. Like I would expect that those would be better at this. Maybe not the JavaScript one, but at least the Java and CLR one.
Well, to be fair, the JavaScript engines are state-of-the-art, super fast things. It almost makes me wonder if anyone is doing that right now, like generating JavaScript source code and to get a finely tuned solution to a problem and sending that off to the JIT. What's the word I'm looking for?
I think it would be really cool if you like in the future when the JITs are better tuned for WebAssembly. I feel like WASM would be like the perfect outlet for something like this.
Yeah.
It's an interesting idea. All right, one of you should work on that. Let us know how it goes.
Okay. Next thing we have is a post on Build 2's website, and this is complete C++ 20 module support with GCC in the newest version of Build 2. And it's a pretty good detailed post talking about exactly what you can do with modules now using Build 2, and they have several examples in here. And if Build 2 is your go-to build engine, it's nice to know they have modules now, and these look like pretty great examples.
This is interesting because how many times recently have we said on the show that it'll be like 2023 before anyone can actually use modules because of build system support and stuff, but it looks like
they're all coming in.
Yeah.
Starting to, at least.
Yeah, I think the one thing I'm curious about is when will the build tools be good enough at modules that it actually like makes
modules worthwhile?
Yeah, like obviously modules are worthwhile for the hidden stuff.
But for like compilation speed and improvements, yeah.
Yeah, that's what I'm most excited about, I think, is the compilation speed improvements. But I have to compile with G++ 7, so I'm not going to be able to use modules for the next 10 years.
7. Wow.
And this does mention that currently their support is tied to GCC because GCC has module support now, but it sounds like it's coming soon to Clang, and that as soon as that is in there, that the Build 2 support should come for Clang as well. So that's good.
Does Build 2 support CL?
Yeah, I was just going to ask the same question, actually.
Like, I think they don't support modules with CL, but did they support CL at all? Like, I don't really understand build 2. I saw the syntax and I was like, nope, I'd rather use CMake. So I'd like to know more about build 2. I don't really know anything about it.
I mean, I just went to their FAQ page, and it does mention that they work with across different platforms and compilers, including GCC, Clang, MSVC, and Intel.
Oh, cool.
So I guess they don't have the module support yet, but they do have some support for MSVC.
That's good.
We've never done an episode devoted to build 2, have we, Jason?
Not that I recall.
Yeah, I don't think so.
I'd be super interested, because like I want to know what's the benefit of build 2 over Meson or CMake, which are kind of my favorite build systems.
Well, since you mentioned Meson, our other post is from Meson because they also are adding C++ module support in the newest version, which is release 0.57. Although their module support is for Visual Studio. I'm not sure if they already had it in for GCC or Clang, or I guess probably not Clang. But they're now using C++ Visual Studio's module support.
Yeah.
I have a question for Nicole here, because I've only just dabbled in Rust, and I see that both Build 2 and Meson are advertising multi-language project support for Rust and C++. And do you just have any gut-like reaction to that? Because, I mean, versus using Cargo or Crate or, the Cargo build system or whatever, and using Meson with Rust and C++, like, what do you see here?
So, I do have thoughts about this, but I need to put them in order.
Okay.
I think one thing I know, at least I'm pretty sure, my knowledge might be out of date, so don't, take this with a grain of salt. But in general, Cargo is pretty difficult to integrate into other build systems. And mostly, I think that's due to Cargo wanting to take care of all the dependencies. So Meson and Build 2 supporting Rust. So Rust. So the really nice thing about Cargo is that it handles all of your dependencies for you. And the unfortunate thing about Cargo is that it handles all your dependencies for you. So it's much harder to kind of integrate with build systems, because each kind of sub-project in Rust, like let's say you have 10 modules, 5 of which are C++, 2 of which are Rust, 3 of which are C. For the C++ and the C, you can kind of control their dependencies from outside and deal with that way. But for the Rust projects, you have much less control over their dependencies. And so having Meson or Build 2, or I'm hoping in the future CMake, have support for Rust means that you kind of have a lot more control, because these tools don't expect to control the dependencies. And it means that you'll be able to integrate a lot easier with multiple Rust subprojects. Does that kind of make sense?
Sure. I think so.
I think so.
And something that I'm interested in, just by virtue of like being myself, is cross-language projects. I think the current world of like literally everything is one language, and there's no like cross-language projects except with a bunch of frustrating C bindings that you have to write.
Yeah, or just maybe having a couple older C files in your otherwise C++ project that happens. Yeah.
Like I think that it's unfortunate that we can't like choose languages, especially for Rust, C++, languages that do work well with other languages. Not like maybe OCaml that has a runtime, but like it would be nice to be able to like write a module in whatever programming language you want and be able to use it from any programming language. And I think that that's something that, NPM, Rust, or Cargo specifically, don't do that well. But I'm not sure. Like there's kind of a lot of complexity here, and a lot of questions of is it better for the user to have less flexibility but it's easier to use, or for enterprises especially, we want more flexibility and we don't care that much about ease of use.
Right.
I don't know.
I mean, we see this in the C#.NET ecosystem, right? People will just mix and match C# and F# at the very least.
Yeah.
Yeah.
Which I think that's really good. I love that part of C# and F#. And I would like for that world to kind of exist in the systems programming world, because I think that Rust is a really, really good language that I want to see adopted more.
Yeah, and that would certainly help with its adoption if you could just choose to have some small module or even just a few source files of Rust in your otherwise C++ code base.
Yeah, exactly. And I think that Cargo makes that hard.
Interesting.
Yeah. Okay, well, Nicole, we have had you on the show before, but it's been quite a while. It was 4 years ago.
So.
And you're, as we mentioned in your bio, you're still in university then. You graduated in 2019. Do you want to tell us a little bit about what's been going on over the past few years? Because you're now with Microsoft
I've been
now, right?
dumping my tea on myself. So I think that the last time I was on was before I went to university.
Oh, okay.
Yeah, so I was at Western for 2 years because I had gotten some college credits in high school.
Okay.
But during the 2 summers that I was there, I worked at Microsoft. And first I worked on Godbolt.ms. So Compiler Explorer doesn't have Windows servers. They actually, whenever you want to do a build with a Windows compiler, that's not the Wine compiler, but the actual MSVC, you call out to us, and I implemented that. And then the next year I did just work on Vcpkg, and so I've mostly been working on making the experience in Vcpkg with C++ package management as good as it is in any other language, is kind of my raison d'etre.
Okay, very cool.
Yeah. Something that has frustrated me for a long time, and actually frustrated me back when 4 years ago, was how annoying it was to have dependencies in C++. And my hope is that with Vcpkg, we are creating a world where C++ developers don't feel like they have to deal with the BS of depending on all of the BS that goes into package or dependency management in C++ and C.
Well, we'll talk about specifically what you've worked on there in a minute, but you said that it's basically been 4 years that it's been frustrating you already. How many more years do you think we have left until you are no longer frustrated by this?
I think most people, if they wanted to, could become unfrustrated within the next 6 months.
6 months. Okay. All right. Then let's get back to what will make us that excited in 6 months.
Yeah. I think that it's very... If you are a normal developer, normal open source developer, using Vcpkg will make you happy and deal with all your dependencies for you, and it's super nice.
Cool.
It's just getting people to actually realize that there's that option and put in the necessary work to actually get that option working.
Right. And coming from someone who's worked in the Rust community and is used to using something like Cargo, Do you feel like it's a pretty comparable experience using Vcpkg compared to other programming languages that have built-in package manager?
I'd say so, especially if you're using CMake with Vcpkg.
Okay.
It's the difference is mostly in how annoying it is to like get set up with developer tools, and installing Vcpkg is still not an amazing experience, but we're working on it. But once you have all of it installed, then the experience of like writing a manifest, using the CMake integration, is, in my opinion, comparable, if not just as good as, using the Rust experience.
Okay.
Except that you have to write 2 files because, you know, it's CMake plus Vcpkg. You don't have one thing that does both.
Okay. So Vcpkg doesn't generate the CMake imports or whatever for you automatically?
No, it doesn't.
Okay.
And we did design that intentionally that way so that, you know, something that people have a frustration with in Rust and cargo land is like system developers, like people who work on apt packages. They don't have control over their dependencies. They kind of have to like either hack up cargo or use cargo to build the thing and download all the dependencies and do all that. Whereas in the Linux world, you want to have like one .so that is this specific library. You don't want to have like 10 different library copies. So Vcpkg really supports that well by not trying to like generate the imports in CMake. Like, you can choose, if you have a project that uses Vcpkg and it's a well-written project, you can choose whether to use Vcpkg or to use your system dependencies or even to use a different package manager entirely. And that was like a major important thing for us.
Very cool. So obviously we've talked about Vcpkg a couple times before on the show. Last year, I think we had Billy O'Neill on, and we also had some members of the Visual C++ team on during CppCon, including Augustin Popa, and talked about Vcpkg during both those episodes. What's kind of the latest and greatest since those past 2 episodes with Vcpkg?
Yeah, so I'm not sure exactly when those episodes were, but I think Manifest had just landed when those episodes were.
I think it was at least announced at CppCon.
Yeah.
When we talked to Augustin? Yeah.
It's honestly been a while. I don't remember. But, so, manifests are implemented. They're not technically stable yet. You still have to pass a feature flag if you're using them from anything that isn't MSBuild or CMake. However, in MSBuild or CMake, you don't have to do anything. Like, in MSBuild, you have to set a variable, but in CMake, you don't have to do anything. You write a vcpackage.json and put it next to your CMake list, and Vcpkg takes care of all of your dependencies for you. It's not experimental with CMake. And we plan on stabilizing it very, very, very soon.
Hey, could we back up a little bit more and just get a little bit more detail about what the manifest feature is?
Yeah, so basically, if you've ever used NPM or Cargo, like the classic experience for Vcpkg and a lot of C++ package management solutions has been install your dependencies with like a command line interface and then build your project using those dependencies. The manifest mode for Vcpkg, what you do is you actually write down a list of your dependencies. Like, I depend on Boost, I depend on Funct, I depend on Zlib. And then you put it down in that vcpackage.json. And suddenly, when you run your CMake build system, we install the dependencies for you, and then you can link to them normally. So there's no like separate step. You just configure and build.
So when you go to link to these Vcpkg install dependencies in your CMake project, what does that look like? I mean, is it just like boost : boost, or do you do like vcpackage : boost, or is there some special way that it's imported, or?
No, it's you going like, if you remember we want to be supportive of like not using Vcpkg if you need
Right.
to. We want to be supportive of those system package managers. And so in order to use Boost, you do what you normally do to use Boost if it was a system installed package. You find package Boost,
Okay.
and then target link libraries, Boost, or Boost system, or Boost whatever.
Right.
Fumpt is find package Fumpt, and then target link libraries, Fumpt, : Fumpt.
You are referring to lib format, I assume?
Yeah, I am, yes.
I've never heard anyone pronounce it before.
I also say stood and unique putter.
Yeah, still unique border I've heard from
Use
that.
that, yeah.
So
Yeah.
I was just making sure.
I'm a big fan of ignoring vowels that are not there, and also vowels that are there, and also consonants that are there.
Well, that sounds pretty handy. I'm curious though, how does that magic work? Like if I do find package in CMake, how does it know to find the one that you just installed with Vcpkg versus whatever one was installed by Ubuntu or whatever, by apt?
Well, CMake gives really good utilities for dealing with this.
You just said CMake and really good in the same sentence.
I know. I actually love CMake. I think it's Stockholm syndrome, but I work on CMake all the time, and it's a bad language, but it's a very good library.
Okay.
And find package, you can set up like your find package search paths, and that's how Vcpkg does it.
So it hooks into that. It says when you go to find Boost or whatever, first look in my directory.
Basically, yeah.
Okay.
There's slightly more complexity going on, but it's not important to understand. For you.
Okay.
And for me, it's very important and very frustrating, but...
I'm sorry, the cynical side of me immediately thought until it breaks. Because, I mean, I'm not saying Vcpkg will break when I go to do this. I'm just saying tools tend to break.
Yeah, especially with CMake, but
Yeah.
I have used Vcpkg a lot with my own projects, and I know a lot of other people have, and usually it's pretty dang good.
Cool.
Additionally, if you have an issue, we are very available. Like, if you go on #include C++ Discord, you can ping any of us, and we're always happy to fix bugs. Yesterday, I introduced a very fun bug, and it was fixed within, at 11 o'clock at night when someone pinged me on Discord, and I fixed it.
That's unfortunate. You shouldn't be rolling out to production at 11 o'clock.
Probably not, but it was an urgent bug. Like it was in master, so it wasn't like in a release version, but
Okay.
Right.
That's an interesting question by itself. So there are actual specific releases of Vcpkg. We're not supposed to live at head if we're using Vcpkg.
you're supposed to live at head, but we're in the process of making it so that you don't. So like Vcpkg has been kind of not experimental, not unstable, but like we have not implemented specific release. We haven't implemented specific SLAs or anything like that, and we're in the process of doing the work to actually stabilize Vcpkg, especially for versioning and registries. Pre-versioning and registries, everything lived in the same repo. You made changes to the tool, you made changes to the libraries, you made changes to the scripts all at once, and it was totally fine.
Mm-hmm.
But with versioning and registries, it's no longer fine to do that anymore. So we're actually now, I'm personally doing the work along with Billy and Robert to make it so that these things are stable. And when we stabilize registries and versioning, all of it will be stable. And
Okay.
we will actually have releases of Vcpkg the tool.
Okay.
So I think you just referenced another new feature that we also mentioned in your bio, which is registries. Do we want to talk some more about that?
Yeah, so obviously we have the main Vcpkg. So a registry is like a set of packages, basically.
Okay.
Okay.
So if you've ever used apt like apt repositories, I think is what they're called.
Yes.
Where you have like sets of packages that you can download and use those packages from those repositories. And Vcpkg has like the main registry, which is at Microsoft/Vcpkg on GitHub. And then we haven't really, up to this point, had the ability to, or like had the ability to nicely have like closed source packages. So if you're an enterprise and you depend on closed source packages, or you depend on your own versions of open source libraries, it's not in the main registry, because we only accept like public libraries. So if you have your own private libraries, it hasn't been easy to use those with Vcpkg. And that's what registries are actually doing, is they allow you to write your own packages that are internal, that no one will ever see outside of your company, and manage them with Vcpkg. It also allows you to do like fun stuff like if you are someone who wants to kind of have like experimental libraries that you don't want to publish to the main registry, you can put them in your own kind of registry.
What is this? Yeah, no, it makes sense, but I do want to, I guess, clarify. So right now, currently, all of the packages that Vcpkg supports is in basically a mono repo of the Vcpkg repo. It has the source code for Vcpkg itself and all of its packages that you can import.
It did.
Okay.
So very recently, Billy pushed through the work to actually pull Vcpkg, the tool, out into its own repo. So that's at Microsoft/Vcpkg tool. And then I'm currently doing the work to pull like all of the scripts, like the helper scripts, out into Vcpkg tool as well. But for now, we're still in the process of doing that, so you can kind of treat them as the same repo. But yeah. Did that answer your question? Okay, cool.
So when you go to make your own registry then, for your internal packages, what does that look like? Do I need to create my own GitHub repository? Can it just be a directory, a subdirectory inside my current project, or what?
Yes, both.
Okay.
We support Git registries, which is what like the main repo is, which you have, a set of versions of. Sorry.
Now I'm looking at my background here.
No worries. Yeah. So Git registries are like the most common, we think, probably people will set up. And it's just like the main registry. So you have sets of a set of packages, and then you have like a set of metadata files that tell you where to find the packages in the Git registry. So in order to support versioning, we have like a set of metadata that point out at which Git object a specific library at a specific version will be.
Oh, interesting. Okay.
Yeah. And so you set up that metadata, you set up the ports backing store, and we call packages ports. They're interchangeable. And then you just simply write a little configuration file that says, this is the registry where I want these packages from, and you're good. Like you have the packages from that registry.
Does Vcpkg today support binary packages?
Kind of.
Okay.
We have the opinion that building from source all the time is the best option.
Okay.
We think that binary packages are usually a bad idea.
Okay.
And if you want most of the benefits of binaries, you can get them by caching the results of source builds. And we have support for that.
Okay, so if I don't do anything special at all, but I've got Vcpkg, I've got 2 different projects that both use Boost, and I compile project A with Boost, and then I go and compile project B, will Vcpkg automatically use the build from project A, or does it build Boost a second time?
Yeah, it uses the build from project A.
Okay.
So you don't have to build twice. It
Okay.
has to unpack a zip file into your installed directory, but it's super cheap.
I was thinking the way you described using Vcpkg, that it will automatically cache those. I would say in all practicality, even though Conan supports binary packages, all the projects that I work on have special flags that we require for all of our Conan packages that they can't use the binaries anyhow. So I just end up having to build them once on my system regardless.
Yeah,
so
exactly.
I think, yeah.
And that's kind of where we're at. Like there are libraries where it is valid to have binary releases if you don't want to release the source code. Although I would caution any companies from using any libraries where you don't have access to the source code. Pay for your source code license. It will save you down the road. However, if you are using a binary package that doesn't have that, you can always just install the package manually in your port file, which is like the package build instructions, and just like download the binary and put it where it needs to go. But we would very strongly recommend against doing that because not owning the source code is very bad, or not having access to the source code is very bad.
This message unofficially sponsored by breakABIcompatibility.com. Is that where is?
Yeah, basically. I would like us to be able to break ABI. I like breaking ABI. I don't like stood regex.
Yeah.
I've been unofficial, like just realized after a few weeks that I basically, or Rob, one of us, has basically asked every guest that we've had on for at least 3 months whether or not they would be okay with breaking ABI. And so far, everyone said, for the most part, they would be okay with breaking ABI. So it sounds like you're in the same camp also.
Yeah, I mean, I think like part of the nice thing about Vcpkg, I think this is personal speculation. I'm not saying that this is true, but part of the reason why Microsoft has been funding Vcpkg is so that we can kind of look at ABI breaking stuff.
Okay.
Like, if we have a package manager, no one's insisting that we put graphics user interfaces into the standard.
Right.
And therefore, we don't have to worry about ABI for packages that you get from a package manager like Vcpkg. You might worry about ABI, but Microsoft, the standard library implementer, does not have to worry about it.
On the topic of graphics packages, I think last time I looked at Vcpkg, it didn't have any of these giant projects like Qt in there yet. Does it now?
It does, yeah.
Okay. Maybe I'm misremembering, or it's been a very long time since I last looked.
I don't really know anything about Vcpkg past like a year ago when I first started working on it, just because I was in university and not doing a lot of C++. But
right.
So I'm guessing if you're going to set up your own registry because you're in a company and you can't use open source libraries, or you want to use your own versions of it.
Yeah.
I'm assuming it's very easy to set up your Vcpkg repository with like your version of a library that already exists on Vcpkg's global registry. Like, this is my own version of Boost that's slightly different than regular Boost. But what if you do have your own purely internal libraries and you want to start sharing them through your Vcpkg registry? How easy is it to set that up?
It's as easy as setting up an internal Git repository.
Okay.
Yeah. One consideration that you have to make is, so I don't know if you saw this, but about a week ago, there was a blog post about breaking companies, like security problems with companies using internal packages.
I did see that, actually. I know. I was kind of thinking about asking you about that. Yeah.
Yeah. So I would link that in the show notes, but
I'll find it.
we we look at things like this and we're like, no, never, ever, ever, gross. We want people to be very, very sure of exactly where their packages are coming from. And so we require that all of the packages you get from a registry, you say that that package comes from that registry. We don't do any kind of recursive registries. We don't do any kind of automatic lookup.
Okay.
We expect that people consider exactly where their packages are coming from and write that down. Because we never want to be in a position where there's a security vulnerability because someone name squatted. You know? And
Right.
we want to be able to support multiple registries without any of them ever trampling on each other.
Okay, so that's something you can do now with Vcpkg, though. You can pull from multiple registries within the same project if you want to. Like, I want this from
with
my
feature
personal
flags.
registry, this one from the global Microsoft one.
Yeah, it is experimental, but with feature flags, you can get that behavior.
Okay.
And I've got some examples in the blog post that will be published, or has been published on Monday.
Has been,
Yeah.
will have
Yeah.
been published.
Will have been published on Monday. So you can see kind of how one would do this.
Okay.
So we are saying by the time this airs, this article will have been published.
Yes.
Okay, just making sure.
Yes. The plan is Monday. So
Right.
if it doesn't happen on Monday, it'll probably happen on Tuesday.
And this is an episode we're recording on Friday, since all of that will sound a little weird, perhaps, to our listeners.
Yeah.
I'm
Yeah.
found myself curious, like, okay, once the package management system is stable, do you still get bug reports? Like, what kind of bugs happen in a package management system? You said you just introduced one in the middle of the night and had to fix it. I'm just kind of curious, like, because I don't really know anything about writing a package manager.
So the bugs that we mostly introduce, or the bugs that I've been introducing, because I've been the one introducing bugs because I've been doing stabilization work, is we have so the port definition, like files, like the thing that tells Vcpkg how to build a package, is written in CMake. And these CMake files have a bunch of helper scripts that they can use. And so, so we can introduce bugs by breaking the helper scripts. And that's what this stabilization effort is doing, is making sure that we know exactly which changes we can make and exactly which changes we can't.
Okay.
And this is because, we've had the scripts and the ports in the same repository for so long, we never stabilized the interface between them.
Right.
But since we're pulling it out, now we have to actually consider stabilizing the interface. And as part of that, sometimes things break a little bit. In the case yesterday, I accidentally broke finding packages from your own CMake libraries, and it was fixed almost immediately. But that happens when you're living life on head, unfortunately.
Do you pretty much then just program in CMake
Yes,
full time?
almost probably 75% of the time.
That has to make you fairly unique. Like, I don't think there's very many people who literally just write CMake all the time.
Yeah, I think you're right. I know much more about CMake than I think most people do.
Than most people want to.
Yeah, I'm close. I'm not at the level of Izzy Muerte yet, but I'm definitely not. I'm not that far away.
Yeah, I would have just assumed that Izzy spent at least a little bit more time writing C++ than CMake.
So is all of, how much of Vcpkg is written in CMake versus what else is it written in? How much of it is CMake?
So
The tool itself.
all of the packages are CMake.
Okay.
The tool itself is C++. So the tool
Okay.
itself, what mostly it does is dependency resolution, version resolution, Git mangling, all the kind of stuff that actually gets the packages and figures out what to install. But the installation stuff itself is written in CMake, just because it's a good build system. Like, it's kind of the easiest way to do that.
Okay.
Does that kind of clear?
Yeah.
What well, first of all, I'm thinking if I as a library author want my library to be usable by Vcpkg, is there anything special that I should do to my library? Or maybe phrased differently, is there anything that I can do to help you as the person who's maintaining this registry?
First of all, use a good build system.
Okay.
Like,
Does CMake count as a good build system?
CMake counts as a good build system.
Okay.
They actually make sure that they work on long paths and on paths with spaces on Windows. Like, you should work with that stuff. Don't break on paths that are longer than 7 characters. Or 13 characters is like the one that I was working on 2 days ago.
Okay.
2, honestly, just look at 1 again. Like, use a good build system. Meson, CMake. I think build 2 is also pretty decent. I don't know much about it. Don't
Not
use
autoconf?
weird... Not autoconf. Not autoconf. Please,
Sorry.
God, no. Don't use weird build systems, though. Like use build systems that people understand. That's CMake, Meson, I don't know, build 2. Please don't use like Basil. It does a lot of like weird stuff. It's
Okay.
good for binaries, but packaging stuff that uses Basil is kind of a pain in the butt.
Okay.
You can use Basil. We do support libraries that have Basil, but it's just much more of a pain in the butt.
Again, I'm reminded of our interview with Patricia from a few weeks ago, discussing how Chromium uses whatever build system they use. It's some random one. Like, okay. So don't
Yeah.
use random build system that no one's ever heard of before.
Exactly. And the reason I like CMake is because you can change almost everything from outside the CMake.
Right.
And that flexibility from the perspective of a package manager is really good.
That makes sense.
Yeah.
Also write modern CMake if you can. It is very, very easy to package a library using modern CMake. Like,
Okay.
Do
nearly
you have to
trivial.
handle like all different versions of CMake that there have ever been in Vcpkg, or you only work
We
with
use
newer versions?
3.18.
Okay.
CMake is very good about backward compatibility with itself.
Yes.
That is.
So if you want to use CMake to build your project and use Vcpkg on the back end, we should support back to 3.1, but we don't guarantee it. Just because we don't test it yet. We have plans to do this, but haven't come to fruition yet. That's not a guarantee. I just said 3.1 because that's the one we know we have to have. Because before 3.1, you couldn't stop variables in if statements from expanding. After 3.1, if you put quotes around variable or around names, they don't get expanded.
Okay.
So we at least require 3.1. But the internal Vcpkg CMake is 3.18, and I believe we require 3.18.
Okay.
So any library that builds with 3.18 could be built with Vcpkg. And in theory, we upgrade decently often.
Well, yeah, if you're 3.18, isn't 3.19 the current highest?
I believe so.
think
I
that's
can't
right.
remember if it's pre-release or not. I'm sure I could look it up.
Yeah.
But
So we've talked a lot about these new features, manifests and registries. Is there anything upcoming that you either want to work on or could tease a little bit, anything like that?
Not really. Like,
Okay.
I think manifest or registries and versioning are like the two big features for enterprise. We're hoping that we're in talks with people to like bring Vcpkg to their company, and that's kind of where we want to be. We want to be, after registries and versioning, we want to be stabilizing. We want to be working with our customers to figure out what is the right way forward, what is the best way to make life easier for our customers.
I am very curious, like how much effort it takes for a company that has, maybe some complex internal build system to transition over to using Vcpkg for dependency management.
Yeah, and I don't think we've had anybody like that yet. Although
Okay.
internal Microsoft, obviously there's some amount of like complexity there, just from a big enterprise. But I would also be curious. I think my feeling is that Vcpkg would do very good in that kind of environment.
Okay. Jason, anything else you wanted to ask?
I don't believe so.
Okay. Well, Nicole, it was great having you on the show again today. Is there anything else you want to plug, Twitter, anything else like that before we let you go?
No. However, I will say I was told by this beautiful, amazing Sai to say that Pure Virtual C++ 2 is happening in April. So
okay.
keep your eyes out for stuff like that, or for stuff about that.
Is there a call for papers or anything, or do you know?
Not yet.
Okay.
I don't really know anything about it. I was just told you should check it out.
Should plug it. So no official link.
More information.
Okay.
No. And we're definitely going to give a few talks on Vcpkg and like VS Code and cool Microsoft products.
Yeah, and for our listeners, Pure Virtual was a great online-only conference around that time last year, April.
Yeah. So we have another one planned, and I think that's all I can say.
I guess I'll jump on that to say also that Phil has made some announcements about C++ on C, again, with more details to come for what it'll look like for the summer.
Yeah, I'm excited to see how that happens. I'm very annoyed I can't go to conferences, because now I'm like in a job where I could like in theory go to conferences, and then suddenly COVID, and now I can't go to conferences.
Let the company pay for it and everything.
Yeah, exactly.
Well, hopefully end of this year, if not next year, everything will be fully back to normal. Yeah.
Surely by 2025, everything will be back to normal. Once we're all using modules.
Yes. I think that's like 2040. I'm going to say 2040. I think that's a very, very hopeful prediction, but I think most people will be using modules by 2040.
By 2040, okay.
Okay. Thanks, Nicole.
All right, thanks.
Thanks, y'all.